Morning, Bob, and the addiction continues. Okay, we just had webinar number 49. Yeah, Uncle Pete just finished his corner number 3, and Bob will do his thing on regular expressions and keywords. So, gosh, we're glad to have you back here, and go for it, buddy.
Okay. Well, regular expressions were always kind of scary because they look so bizarre, and it's really a whole nother language. And so I decided that I really wanted to learn regular expressions because the match regular expressions function in WINDEV actually works and is actually very powerful. Clarion was rather weak. It only allowed a fairly limited use of it, and it wasn't really worth learning because you couldn't use it very well. Match regular expressions in WINDEV has a couple of different formats, and let me just bring that up because I think it's interesting to note. Come here, you. Okay. Match regular expressions has two formats. There's one that's just yes or no. Yes, it matched. No, it didn't match. And that's this syntax here. Okay, where you give the expression and the format that you want to use, and it returns true or false. And that's okay. But the really powerful one is this one, checking a format and retrieving the elements that correspond to that format. And this is the one that I'm going to be demonstrating today. And that is, you have your expression, you have your format, and then you have the variables that you want filled in. And the interesting thing about this is there's a tiny little note here at the end that says, actually, I guess it's the third format, that says retrieving the elements into an array. And this is incredibly powerful, and this is the one that I ended up using, and it's so much more flexible. I got this hint from technical support, and I said, really, you guys need to change the, give an example of this type of use, because this is really the powerful one. So, in trying to put this thing together, then I realized that it's nice to start simple with a regular expression. So if you have, for instance, a regular expression of just, you want to match a word. Okay, that's the regular expression. And if we say, oh, it makes it all uppercase. I think it says no match. Well, it doesn't match. Let's try this. And it still says no match. Let's put this. And now we got it. Okay. Because I'm using grouping, I have to set up the first group.
Bob?
Yeah. Yep.
Can you just kind of give me an idea? I mean, I don't know anything about regular expressions, okay? So can you just give me like a paragraph of what this is?
Okay.
I know most people know, but I thought...
There's a regular expression. And what this is a way of going through something like this phone number and picking out and matching character by character, group by group of this thing. So in this example here, this weird expression actually fills in 3 variables. It pulls off the area code, the exchange, and the phone number. So it's instead of having, Pete was talking about if clauses and lines of code. This is
so this is a way of parsing things out based on some pattern or something?
Yes, exactly. matching a pattern. That's what a regular expression is it matches a pattern. And in addition, you have the option of pulling out the pieces of that pattern, and that's the real power of it. So you can say, yes, does this match this pattern, true or false? And that's one piece of information. Or you can say, does this match this pattern? And, by the way, what are the pieces of the pattern? And that's what I'm doing with this one.
Okay, so it's matching patterns. Okay, so you're going to show us a simple one now, right?
Yeah,
okay.
I will.
Got it.
Okay, so let's just say that we wanted to match, and I have to start with a group. We wanted to match any letter of the alphabet. Okay, so that is going to be A to Z or A to Z. Okay, this represents one character. Okay, whose value is lowercase letter or an uppercase letter. Okay, so A matches. Now for purposes of this example, I always uppercase target. Okay, so that's why when I type a little a, it comes out a big A. That's just for information. So this matches one character. So if you had a user, you were trying to evaluate what a user entered, and you said, okay, look, you enter one alphabetic character. Now, before you would say, okay, if this character is greater than or equal to little a and less than or equal to little z, or it's equal to greater than or equal to big A, and less than or equal to little z. I mean, there's a long if statement. But with this one statement, you can prove that the user has entered one alphabetic character. Because watch what happens when I enter a second alphabetic character. Oops, no match. So, hey, user, I told you only one character, and you entered two. No match. All right. But let's supposing that you wanted to match two characters. Okay. You could say curly brackets 2, and now it matches. If you have one character, it doesn't match. If you have 3 characters, it doesn't match. So you have said now in the regular expression, hey, take what went before this and only match it twice. Okay. Let's supposing that you said that I really want to make sure that the user enters something and I don't care how long it is. Well, a plus matches one time or more. So if you put a plus there, now 3 A's match, 2 A's match, 1 A matches, no A's don't match. So it's a language, you just keep adding conditions onto this thing. All right, so that's one alphabetic character. But look, numbers don't match. But if you wanted to allow numbers, 0 through 9, and now it matches. So this inside the brackets represents one character. And it can be this, or this, or this, or say you want to allow only A, B, or C. Okay, now this string doesn't match, but an A does match. An H does not match now anymore. Only A, B, and C match. Question?
Yeah, when you had the curly brace and you put a 2 there,
yes.
If I wanted 4 of them, would I put 4 or would I be curly bracket 2, curly bracket 3, curly bracket 4?
Okay, curly brackets are in the min, max, or count. So you can have, supposing that you wanted to allow either 2, 3, or 4. Okay. Now you see I have 4 of the characters A or B or C, and it matches. But 1 does not match. Okay? So that's how the curly braces fit in.
So if I put 3 in, it won't. Oh, 2 or 4. But what about
2,
3?
3 or 4.
So
minimum to maximum.
Oh, I see. That's the range. That's the range.
If there's 2 numbers, it's a range. If there's 1 number, it's got to be that number of them.
Got it. Okay, thank you.
Okay. Now, I had placed a plus sign there, but if I use an asterisk instead, that says 0 or more. So this is now an optional part of the expression. So you can have nothing, and you see it says it matched. And there was nothing there. So if you wanted to make sure that this ABC was at the beginning of a line, you put a caret in it. If you wanted to see it was at the end of the line, you'd stick a $sign in front of it. And you see the groupings that we have here. You have to, for the purposes of this example, you have to be grouping. And let's supposing that you wanted your character to be a bracket. So in order to not confuse, because if you just put in a square bracket here, well, it's 0. Let's see. Let's require, yeah, that's good. Try an end bracket. Okay, it says format error. So if you wanted to include the character, oh, it doesn't belong there anyway. If you wanted to include the character of a square bracket, you put an escape in front of it, and now you can have character. That's interesting. That didn't work. Should have allowed 1 square bracket. That's some of the fun of regular expressions, is sometimes things don't go the way you sort of expect that they would. And that's why this is a nice little plaything, if you will, to be able to dynamically build expressions. Pardon?
Bob, why do you have the starting? Why do you have the starting and ending brackets? Why don't you just have a / bracket?
Well, I could. Haha. Very good.
There you go. You were testing this, right?
I was testing to see if you'd pay attention. But you see, if you put something else in there, it doesn't make sense. It doesn't match. So let's see. So if you wanted to allow A to Z, now this is where the brackets come in, because you see, you'd think that would, hey, I want a bracket and then I want A to Z. Well, that matches only this expression. If you wanted the letters A to Z, that's where the square brackets come in, because that says 1 character whose value is A to Z. And now I have 2 characters specified. One is is an ending bracket, and then 1 A to Z. So if I take these 2 off, now it matches. If I wanted to allow additional letters, I could say asterisk, and now A, B, C matches. So that's, the square brackets delimits a single character position. And that's how they let you say the range of the characters, or let's say that you wanted only the letters A and Z. Okay, so I have a single character position and I only want the letters A or Z there. Well, as you can see here, I have a B and a C. But if I take them off, now it matches. because I've said I only want A's, whoops, and Z's. And the 0 says repeat, the asterisk says repeat 0 or more times. So having none there matches just as well, because that's a 0 times match, and the square bracket matches. But if I take the square bracket off, and now I have A's and Z's, they don't match because I have said this must start with the ending square bracket. Is that clear?
Yeah. So if I had like if I could do a bracket and then I could do a letter and then I could do a number, I would have that instead of the star. I would have bracket like 0 to 1 or something.
No, you'd have curly braces. If you want,
it would be curly braces.
If you
like
want
say
to
I want
control
the third.
the number of them.
No, not the number. I wanted a digit next.
Oh.
Would that be another square bracket?
If you wanted only one letter, and then you wanted a digit, 0 to 9.
Right.
Okay. So you see AZZ doesn't match.
Right.
And square bracket AZZ doesn't match. But square bracket A or Z or 2 would match.
Okay, so each character could be a bracket. Okay, got it.
Okay. So
God, you're making this clear to me, man. I've never. I was scared of this regular expression stuff, man. You have making it way clearer.
That's what I'm trying to do, because it is a scary topic. It absolutely is. And I put it off for a long time. I bought books on it. I searched the internet on it, you know, and I just couldn't quite wrap my head around it. And I finally decided that I really needed it, and so I was just going to conquer it. And you know, now that you see the methodology of doing this, you know, character by character, let's take a look at something that's simple in its content, but yet can be kind of complicated. Let's say that you've got a phone number, and people can enter phone numbers in all kinds of different ways. You've seen them +1, and then parentheses around the area code, and a dash between the exchange and the number and everything. And you can think about how many if statements it would take to unscramble that thing. And yet the regular expression can do that in one statement. I can name that tune in one statement. So let's take a look. I know this looks terribly complicated, but it's not. And we can break it down piece by piece. Okay? Square bracket set, and you'll notice that there's a blank space in between there. I can have 0 or more leading blank spaces. So if I have blanks, it still matches. So you can kind of think of this as consumes. These 4 characters up to here consume all of the initial blanks. Okay. Now the next character is a plus sign. And the question mark says I can have 0 or 1 pluses. Okay. Well, in my example here, I have 0 pluses. Then the next one is a 1. And a question mark says I can have 0 or 1 ones. Now, this is not international. This is only for U.S. phone numbers. Okay. Then next is another blank. And I can have 0 or more blanks. And then I can have, and here's our escape character, a paren, the left paren. And that can occur 0 or 1 times. And now here's a paren because it's not escaped. It's a grouping character. And this is where the area code begins. Now, all area codes begin with the letters 2 through 9. You can't have an area code that begins with a 0 or a 1. And so this says the next position that you encounter must be 2 through 9. And we're working down here now. We ate all the blanks between the 1 and the area code. So 2 through 9 for one character. 0 through 8 for the other character, and 0 through 9 for the third character. I didn't know you can't have a 9 in the second digit of an area code, but you can't. Then the closing grouping character, because it's not escaped, is a parenthesis, and then an optional question mark, closing right paren. Okay. So that takes us now up to the end of the area code, and the next character can be a dash, a period, or a blank, occurring 0 or 1 times. So I'm not going to allow multiple blanks, although I could have, I think, coded that in there. Now we got another grouping character, and here's the exchange. And again, exchanges can't start with 0 or 1, so I have the characters 2 through 9 for that first character position, and then 0 through 9 for the next 2 character positions, and there must be exactly 2 of them. Then we're going to close the group. That becomes the group for the exchange. And now we're going to open up another group. We'll move on to the next character position. And that one can be either a dash, a period, or a blank, occurring 0 or 1 times. That's interesting. I think we can even leave out the space. We'll experiment with that in a minute. Then we open up another group. And you have 0 through 9 for exactly 4 digits. Close the group, and then eat all the trailing spaces. Okay, now what if you said, wow, I really want to know whether or not the user entered a country code? Okay, the country code is here, so we can make that a group. And you want to know whether or not it had a plus. Okay. So now we have the country code, the area code, the exchange, and the phone number. Then we said that what if we wanted to have the phone number without spaces? Okay. Oh, would you like to break that down for a, Okay. Yep, there's my phone number. And yet, this same expression that we wrote can break that into the corresponding pieces. Just imagine how many if statements it would take to parse that thing out in that many different variations. That's the power of regular expressions. He wants to know what happens if I take off the 1.
Yeah, okay, you see that.
All right. So now there's no country code. Okay, so when you examine, and we'll look at the code here in a few minutes, but when you look at the array that this parsed into, you'll see that the first subscript will be empty, which says, hey, user didn't enter a country code. Then the next one will be 234, the next one, the area code. This one will be the exchange, and this is the number. So
each one of those rows is a group, right?
Each one of these, yes, yeah.
Every
group goes into an array element. That's the power of this thing. And so, as you can see, the number of these things has varied. Because when I added this group for the country code, okay, see the number changed. And when we were looking at the help before, here, when you were looking at this fixed format, variable 1, variable 2, variable 3, I kept blowing up because sometimes what I wanted to parse wasn't there. And that's where because I didn't know about this third option for the array. And this is the one where if it's not there, it just drops that array, element out of the array, and you just start earlier. So that, that's all numerics. Well, what if you had something and this was something that came up in the class with Glenn. He was parsing out a select clause, and he had, select last name, first name, and the likes value from the people database where the sysID equals 1. And he needed to break that down and find out, what the different pieces were. And I said, that looks like something for a regular expression. So I started playing with it and found out that yes, in fact, we can do that, break this thing down. And the way that one works is select, must match select. And I just uppercase the target so that to make this easier. Because I'm not sure. I have to play with this a little bit to see, upper lowercase s, upper lowercase e, upper lowercase l. I don't know that if WINDEV has a ignore case option for this or not, but in any case, we'll just talk about what we've got here. So SELECT matches exactly, okay, and a blank. That blank is significant there, okay, and I've said plus sign, one or more blanks must be present. So we could have additional blanks in here, and that would not mess up the matching. Okay, then we start a group, and then the first letter of that group must be A to Z. So you cannot start a variable name with an alphabetic, with a numeric rather. Then after additional characters are A to Z, 0 through 9, underscore, comma, or a blank. And there can be 0 to or more of them. Okay. Then another blank, one or more. And then the letters FROM, one or more blanks. And now we're going to start another group. And that group is going to be, again, alphabetic at the first position, alphabetic, numeric, or a star, escaped there, star, or an underscore character. And then there's going to be one or more of those in there. And that's going to be the second group of the from clause. Then we're going to start another group, and that's going to be the where clause. And there's be 0 or 1 or more blanks. 0 or more blanks. Yeah. Maybe there should be a blank in there, a required blank. So that should be, instead, that should be a plus sign. Okay, WHERE, and then there should be a required blank there. And then the period or asterisk characters. And then we're going to have another group for the order, and it can be order or order by. No, I'm sorry, order by, and there has to be a space between the order and the by. And then spaces here, and then an asterisk or a period. And that can occur, that whole thing can occur 0 or 1 times, and a terminating space, and then the whole group can occur 0 or 1 times, which means you don't have to have a where clause, and you can still have a match. But you can't have a space at the end, because I didn't code that, okay? So that's how you do alphabetic, statement kind of parsing. Dates. Okay, you want to separate out month, day, and year.
Bob.
Yep.
Well, Bob, Chris has a question, but if you look at the legend there, Chris, you can see on his left side, he has a legend. So your star there means 0 or more. So you got your star, plus, and question mark is what I'm understanding that controls
exactly
the character.
That controls the number of iterations that you allow. And you could always use the curly brackets, okay? For instance, a star is curly bracket 0, comma, 99999 kind of a thing. Okay, wait a minute. Something popped up here. He said, no, what he said was what? I didn't. What is it? Period character means any character. Yes, I don't have that in my legend. I apologize. The period is any character. You're absolutely correct, Chris. I screwed up here. I forgot. In this case, the period is only a period because I have escaped it. In the example of the select clause where I had the period here, that's any character 0 or more times.
So period is
So
another
Yes.
one of those that should be in that group. Okay.
Yes, it should have been in the
Wow,
legend.
that's hard to see some of that sometimes. Okay.
I apologize. I should have made this bigger yet. Yeah, that's a good point. I will add that to that. Thanks, Chris. Dates. So parsing dates is kind of an interesting thing because people can write dates in a variety of different ways. You know, they can separate them with dashes. They can separate them with slashes. They can separate them with spaces. They cannot separate them, okay? But yet, why? Okay, the reason things don't match, that's why I wanted this as an example. The reason things don't match is I said that 0 through 9 3 times. Month, day, year only has 2 times. And now it should have matched, you little rascal. What happened? Blank, 0. Oh, maybe you can't do. Okay. So when I put the spaces in, it matched, but that doesn't match. Okay, so 2 characters and a dash or a blank or a period.
Oh.
Okay. Yeah, I have to have a separator.
Nothing?
What is a nothing? That would be any character 0 or more times. I'd have to play around with whether or not there's a way to code a nothing in there so that, but this will take separations. There has to be a separator character. Okay.
Okay. Okay, got it.
Okay. Got to have some kind of a separator for month, day, and year. You can't string them all together. But
that's probably because in case it was 1 digit, right? That's because in case it was 1 digit. Is that?
Yeah.
Like if it was 9.
I will not allow. January 1st, for instance, cannot be written that way. It must be written that way. January. Okay. It would be possible to code 0 or you could have a let's see, you could have a 0 or a 1. Let's see if we can do this. Take out this 2, and you'd have the 1 position can be a 0 or a 1 occurring 0 or 1 times. Okay. And that matches.
Oh, yeah.
And then 0 to 9 occurring exactly. And that has.
That's dangerous because you can have 19 when we really could only go to 12.
Yes, and that's what I was getting at. So if there is, there's probably a way to do it. I don't think I want to take the time now to to try to figure it out.
Can you do like a range of numbers? Like 1 through 12?
Well, you have a 0 or a 1, and then if you have a 0 or a 1 there, then you only want to allow 0, 1, or 2. If you have a 1 there, you only want to allow a 0, 1, or 2. I don't know.
Oh, yeah. So you can get that tricky with this regular expression, huh?
That's for the advanced webinar. I don't know if that one would do it.
Maybe Chris can figure it out for us.
Yeah. That can be very dangerous.
Wow. No, that was before. That was before.
No, he's got a different, very dangerous in RE. Okay. No, I am specifically looking for a period. But anyway, that's dates. And then social security numbers. Okay, again, people write them in various ways. Sometimes they'll have a blank in there. And it's just a way of parsing it out and it requiring exactly 3, exactly 2, and exactly 4 in each group. Either a dash, a blank, or a period between them. Leading spaces are optional. And so I'll have the source code for this little program so you can play with regular expressions. And I found it very, very handy to be able to sit here and compose a regular expression and, you know, have every little thing I do get constantly evaluated and tell me whether or not I made it, whether or not the regular expression had a format error because something wasn't closed up or whatever. So, and then when you get a regular expression that you like, then you just click this button and it'll copy this and you can paste it right in your program. Okay, so what does this look like? What's the code behind this thing? And,
hey, can you put the point period in there while you're there?
Yeah, I can.
Oh, maybe not.
Make a bit of room. This has got to come down.
Oh, sorry. Shoot.
No problem. And then we'll just copy this. Actually, there is something in there. I can't just put it in there. That's why I...
Yeah, that's a status.
Yep. Period equals... Okay. I'll rearrange those to get that one back up into... Well, it kind of fits there. Okay. So, what did I do to do this? Okay, well the code is all behind this little button here, and so I define the array that I'm going to use, and then NN is the result of the match regular expression, and I have the target field, the regular expression field, and my array name. That's it. Okay, that is everything that it takes to get the information out of the matching and the grouping and everything. So then I just display it in the table so that you can see it. So I clear the table. If it matched, then loop through the array and add that line to the table. Add that value to the table. And then make the caption say success and put a smiley face on there. Or if the irregular expression didn't match, oops, no match, and a frown. And then display the results. Now, it turns out that if your regular expression is not valid, WINDEV will throw an exception. So I kept getting that separate screen, you know, it says, you've had an exception. So I said, all right, when there's an exception, and I had never used this before, so you just click up here and it puts in case exception. So when this thing has an exception, I change the response to format error, and then I put the little mixed up symbol on there. And that is how I do the displays.
Cool.
So
that's really cool.
When you have, a regular expression here, and you have a format error, okay, there should have been something in the brackets, but now there's no match. So anyway, it just sits there. Oh, that's the other part of this. There is one other little piece to this thing, and where'd it go? Let's look at code, all the object codes, and whenever modified register regular expression, okay, execute the process, click on the apply button. So every keystroke that you type in a regular expression, it doesn't apply. So that's how I got it to be dynamic. And the same for everything that you type in on the target. Every character, it reapplies the whole regular expression. Kind of like an immediate, huh? Yes, exactly. So that's what gives this example. I think kind of its really coolness is that this thing is done for every character that you type in. It runs this code, and so you get immediate feedback. And then here's just filling in the buttons with the values that I had. And that's the program. Any questions on that?
Wow, I love this. Let's see. Chris says, does MatchRegularExpression put every match into the array?
If you have it in a group. If you don't have it in a group, it does not. For instance, the original phone number example, here's a match to the leading blanks and then the country code, and it does not appear in the array. It didn't appear in the array until I put the group around it. And I said, I want this to appear in the array. And this is something I have not explored real heavily, but you can group groups. So if I wanted country code and area code group is right there. Oh dear, we're not matching anything. Okay, so now I have one array value for area country code and area code, and then I have them separated. So you can get really crazy by grouping the groups. Wolfgang says yes, makes it easy to play with, and that was the whole purpose of this thing. I think if you can play with regular expressions, it does make it a lot easier to deal with it. And in putting this webinar together, I learned a lot more than I knew before I even started the with this application and trying to do that. Oh, and then, yeah, this is down here. I just wanted to show the entire bit of logic code that goes behind matching these two things. And it's just match regular expression, target expression, and array that you want the results to go into. Anything else? Any other questions? Do we have time to talk about keywords or somebody? Anybody? Hello? Anybody out there? Can you still hear me? Oh, okay. You just hear me. All right. That's all I have for this. If there's no additional questions and there's time, I'll do keywords. Arnold, you there? Okay, well, let's try keywords. One of the things that has frustrated me about positional parameters is that it's not very clear, although WINDEV, I admit, makes it a lot easier when coding because it gives you the IntelliSense of what the parameter name was and sometimes a little hint about what it means. But when converting my component into a .NET module assembly, I learned that those optional parameters that I had specified that worked so nicely in WINDEV are a nightmare in .NET because you have to have, how to say it, it's considered a procedure overload, and so they have to specify a separate procedure call for each one of those things. So if you have 3 optional parameters, you call the procedure, then you'll call procedure _1, procedure _2, procedure _3, based on which optional parameters you have. And it was a nightmare. And I really didn't even want to try to document anything like that, so I said, fine, I will only have one parameter that I will pass, and then I will do my own parameter parsing. And so then I decided that I might as well use keywords. So for instance, if I have a procedure that takes 3 parameters, one is a clear, true or false, the starting day that I want this procedure to have effect, and parameter 3, which has a default of null, but can have a variety of values. Okay, so if I code the parameters here, and I just say like clear equals false, comma, start, and I can abbreviate the parameters, Thursday, and P3 I'm going to just leave off and then call it. Okay, so the clear value is now 0. The starting day is Wednesday? It didn't, that's interesting. All right. I thought I could have abbreviated that more. Oh well. Starting day is Thursday, and the P3 is null. I can mix these up. So I could have this thing go there. And now the clear value is false. The starting day is Thursday. It didn't matter. So that's one of the advantages of keyword parameters, is that there is no requirement that they must be in a specific order. Also, I made it so that if you specified a positional parameter when you call the module, it will apply to the first parameter, first keyword, if there was no overriding keyword specified. So supposing that in my example I said false, and then I said start day equals Friday. Okay, so clear value was supplied the value false, and the start day was Friday. But clear equals true, clear value is 1, and oh, that's the other thing is that if I detect true, false, yes, no, 0 or 1, they get translated to 0 or 1, so consistency. Because what I have, my product for QuickBooks is a programmer tool, and so it's programmers that are using it, and it's programmers that are coding the parameters to the calls, not an end user. So, they would understand this kind of a thing. So I just thought I would show the code behind that. It's not very complicated. This is the workhorse. It does parse parms. You have the array that you want the parameters to go into, a string that contains the default values, and a string that contains the actual parameters themselves. Okay, to set this up, you have your array for keywords. The first parameter, this is just a working field, a truth value, which is another working field, and something to tell whether or not a match has occurred. Okay. Then we're going to parse out the defaults. So we set up the default values as into an array, and the parameters themselves into an array, and then use string to array to divide those up based on commas. Comma separated list goes into the array 1, 2, 3, 4, 5. Okay, clear out the parameters, and now we're going to slide the defaults into the array, and we're going to use an associative array. Interesting. Okay, the actual array that contains the values, the final values of the parameters, comes from here, and it is an associative array. And I think that's all you need to know. This clears it out, and then we're going to loop through the defaults, and we're going to split the defaults based on the equal sign. So we'll have a parameter equals keyword. And so then the parameter is going to be array keywords sub 1, and the value is going to be array keywords 2. And to make things consistent so that no matter how the programmer spells the keywords, I'm going to uppercase and only match on uppercase for the keywords. The values will retain their caseness, if there is such a word. So, if the parameter default coming in contained an equal sign, then the occurrence of that split up here is going to be greater than 1, and I'm going to assign that default value to that keyword. So the keyword becomes the subscript in the associative array here. And that's the power of associative arrays, is that subscripts are character strings. And so you can have array name sub and then the character string clear equals 0 or 1. Okay. Otherwise, it just puts the keyword itself in as the parameter value. And if the very first parameter, the very first time through the loop, it remembers what the keyword was, and that comes in if we have a positional parameter to fill into the first parameter. Okay, so now we've got the defaults positioned in our associative array, and now we're going to actually look at the real parameters themselves. And if there were no parameters, for instance, okay, let's just say the actual parameters occurrence is 0. The defaults now are filled in, and everything took the default. But let's say we do have parameters. So we take the actual parameters and split them one by one on the equal sign. And again, uppercase the keyword, take out the spacing. Okay. And another little feature is that you could say no clear, no underscore clear, and that would be the same as clear equals false, or clear equals 0, or clear equals no. Then if they did have the keyword no, then what I do is I take and skip the NO underscore and start at position 4 to the end and set that as the keyword. So clear, if using no clear as an example, clear would have a truth value then of 0. And if the word no wasn't there, then the truth value is by default 1. And this is, again, this is just a working value that will be used a little bit later. Okay. If the string ends with equals no, set the value of the parameter to 0. If it ends with false, set it to 0. If it ends with yes, set it to 1. If it ends with true, set it to 1. All right. So now we're going to actually match the keyword. Because the keywords can come in any order, and the defaults were in a specific order, I have to search through the original array looking for a match. And I also wanted to allow the abbreviations, and I don't understand why start didn't accept it, but I'll have to look at that. But anyway, a string starts with the whatever the user specified for a keyword, then, and ignoring punctuation and space in case, then assign it. And if it doesn't start with that, oh, if there was an equal sign, in other words, if the parameter that was passed was specified as something equals something, then take the parameter value and assign the keyword. If it was not an equal sign there, that means then that it was of the format clear or no clear, and just assign that truth value that we found from up above and indicate that we had a match. And it will loop through each of the past parameters and fill in the corresponding value, overriding the default that was originally stored there. Okay. Now, if we got all the way down to the end and nothing was matched, I'm sorry, if we were doing the first specified parameter and nothing was matched, then that's a positional parameter and assign it to whatever the first parameter was. And remember, up at the beginning when we first parsed this thing out, we remembered what the name, because this is an associative array, subscripts go by name, remembered the name of the very first parameter, and so then we assign that value, the first passed parameter, to it. And that's it. And here is the call of that, and I have said that what I'm going to pass is an associative array of strings. And I said, parse out the parms. This is the name of the array I want you to use. And these are the default values. And here are the actual parameters. And you see, this is what was passed. I just carry it forward. And then this is the result. Clear value is whatever the array value subscripted with clear is. And remember, I made everything uppercase. And then the starting day is whatever start day is. And P3 is whatever the value of the parameter sub P3 is. And this becomes then, whenever in your code, if you were using this, you would just simply, wherever you wanted to know what the value of the clear parameter was, you would just simply put in parms clear. And that is the value of the clear parameter, whether it was defaulted or whether it was specified. That's it.
Yeah, did you look at Wolfgang's message?
It's really pretty simple. No. Okay.
basically says just that you know, you can also use the following. Keyword not equal to test word is the same as doing keyword equals upper, no space,
it's approximately equal.
test word.
It's approximately, yeah, it's approximately
equal?
Yeah, Arnold, it's approximately equal, not a not equal. Yeah.
Oh, I'm too clearish on that. Okay.
Mm-hmm. Yes. Very good point. Thank you. Any other questions? The source for this will also be available if anybody wants it.
Another good day of 3 great topics. Thank you for studying this stuff and making it really clear.
Well, Pete's example for the conditional string concatenation is cool. I sort of remember reading it, but I had kind of forgotten just how powerful and useful it really was. Seeing the dynamic examples makes it come so much more alive than just trying to read it in the help text.
Oh, no kidding. So we just need more of these. So thank you for studying for us, and whoever else comes up with little great tidbits like this. It's major, I think.
It is. All right.
All right. If there's no other questions, claps again. Bob, stay addicted, okay?
Okay. Will do.
Okay. Stopping.